multi-million-dollar mistake. And there are plenty other such mistakes in our industry. The softness of software is what allows these kinds of problems. I guess most of us work in what we call the tech industry. Is this media tech? Is it transportation tech? What is tech? So Wikipedia calls these companies as information technology companies. And within the ambit of information tech, there are two sub-concerns: information management and information processing. Gathering, refinement, storage, representation, transmission, refinement, retiring, dissemination of knowledge, all of this fall into the bucket of information management and information processing. What is information? Information is yet another vague and abstract concept. It can be a constraint, it can be communication, control, data, blah, blah, blah. This is, I picked this from Wikipedia. By the way, feel free to interrupt me with questions at any point in the presentation. What do we folks do on a daily basis?
That's code more than I
So,
actually cut copy paste.
Copy. So this is a metric I got from how many lines of code people write on a daily basis. I don't trust this number, but assume that people who are in the first 5 years of their career write 100 lines of code per.
Which language?
This is about the independent of languages.
I would really take that with tons of code.
Yeah.
Writing 100 lines of C code is a lot more difficult than writing 100 lines of Python.
That's a different conversation, but the hypothesis is it is pretty much the same across languages.
So you mean that all line of code includes the Stack Overflow questions also?
We'll come back to that. This is supposedly typing speed of average human, between 38 to 48 words per minute. So if we take 100 lines of code, I guess we'll be done in 15 minutes. I guess what do we get paid for the remaining 7 hours and 45 minutes? So besides browsing social media and coffee breaks and food tables and meetings, I guess this is where we spend our time. Gathering of requirements, analyzing them, reviewing code, reviewing design, brainstorming, debugging, looking at data, looking at metrics, documenting stuff, right? Reading documentation, planning, meetings, updates, retrospectives, production issues, blah, blah, blah.
And refactoring your previous slide.
Now, if you go back to the definition of information management, you see, this is pretty much what we do. We may be working on our laptops, but all we are doing is information management in one form or the other. Agree, disagree? Okay, I'm done. So, this is a typical representation of what in software engineering. Let's take the example of Uber. Some product manager in Uber figures out what is happening in the real world. They look for cabs. The cabs are there in the real world. Drivers are there in the real world. they need to track their location, onboard them. So they'll interact with developers who develop code on their laptops, desktops, push it to production, and machines communicate, and so on. The traditional representation and interpretation of information technology seems to be in the world of data. We gather data, we process data, we refine data. I'm proposing a hypothesis that it is a lot more in our world, like we spoke about in Paris. In the rest of this talk, I'm going to draw parallels from within software engineering as well as other disciplines from the lens of information management. I hope to inspire upon you that there are learnings we can do as software engineers / architects. I'm restating the context of software engineering. Information is data, code, design, metrics, requirement, communication, and so on. This is a more nerdy way of saying information can be instruction. Information can be data. Information can be communication. Okay. Why do we normalize data in databases?
Because we avoid consistency. We avoid redundancy. We don't want data, as is mentioned, consistency. But another thing is, I would also say it is also a relic of the past, because then you didn't have too much disk space, and that's why you have the right to call. Possibly data normalization is also a holdover from those things. No SQL databases, you don't really want to normalize the stuff and do it.
Okay.
So that's just
Talking about the last thing, the world is moving towards new SQL, where you're talking about SQL on top of different underlying text, definitely. But the very first statement he made is we avoid data duplication. Why is that a problem?
Storage, maintaining the consistency is the source of truth.
Why is it important?
Inside the
There should be a single source of truth for any
Why?
the insights. Because otherwise, like, you will not be able to determine which is the trustworthy source.
Yeah. So
there is errors. There is some amount of errors in all the
yeah,
data.
a class of problems emerge.
So then there's like other issues because you are copying from the errors.
Yes. Some classes are the insertion anomalies, update anomalies, and data delete anomalies.
So philosophically speaking, and rather going to that point, a single source of truth may not be the most appropriate thing for society per se. I'm not talking about computing, because different perspectives may not exist. We have these simple sources. Just go back and talk about religions in that. Work with them.
Now, the software engineering principle of don't repeat yourself
Right.
can be thought of data normalization. It's a parallel to data normalization. Why we want a single source of truth in the data world, in the instruction / information world, we still want a single source of truth. That is the takeaway from the don't repeat yourself principle. What is true for data is also true for code. Continuing on this is the teaching of one of the normal forms. Every non-prime attribute has a full functional dependency on a candidate key. If that is not true, those attributes have been moved to a different relation. Again, if you draw a parallel to the code world, anything which is not dependent on the core of your code should be moved out. This is single responsibility principle. If you do this and if you apply the right principle, you end up with separation of concerns. Now, I have known engineers who fight for normalization at database level, but are happy with code duplication. They are equivalent to our leftist media.
I just want to mention one thing here. I don't see an exact parallel between data normalization and don't repeat yourself, because you don't repeat yourself. I'll repeat what I said. I don't see an exact parallel between data normalization and don't repeat yourself. The reason being that don't repeat yourself does not apply to code so much as it applies to domain knowledge. For example, let's say you have some complex calculation in your code, involved processing a lot of complexity. That is a prime candidate for don't repeat yourself. But if you are duplicating some straightforward database calls, etc., that should be perfectly acceptable. You are giving up centralization of code in some aspects for other gains. So that is my take on don't repeat yourself.
So database world has the reason for normalization is to prevent insertion of date and delete anomalies. The exact same problems exist in the behavior world. There is a difference between importing and reusing that code versus copying and pasting it.
Having the same function 5 times instead of writing another function, just reduplicate that code in different places where once you change one variable, you forget to change the variable. It's a common thing that we have all done with our things.
I would say it is not normal. It is at least a few $100 million mistake if you were to draw a parallel with the coming power analogy. But yeah, this is what I was trying to challenge in this talk.
There's other one thing also, right? Keep it simple or something like that.
Yeah.
That's one principle, but
Keep it simple.
Right. Don't repeat yourself. That's it.
Sorry.
Yeah, but the takeaway
Do one
is,
thing and do it well.
yes, which is kind of single responsibility principle. Again, we were talking about NoSQL and SQL, old SQL world, normalized and denormalized data. I, as an architect, if I had an option, I would always go for normalized data because the integrity of my data is better. So the day NoSQL databases become the norm, I would be one of the first people to ditch NoSQL in terms of NewSQL. Again, going back, I've seen engineers who want normalized data model but denormalized code bases. There are reasons for it. There is local view of data, behavior versus staggered and scattered. For some reason, this following of chain of references, I'm told, is hard.
Okay. So the practical example is when you are writing code and you have to do system calls and function calls and those will interface in another file and all the way down the line. That is the sort of a thing where you could do with C tags, star, and do it in Vim and go through that. But that I think is the sort of the challenge that people can talk about, the following the chain of references. Where does this function reside? What does this function call? So that getting the call pretty right and all those things are the
Yes, but if the same principles will give you better abstractions.
I'm
Yes,
not denying that, but I'm just trying to say that that is the real practical problem. Just to tell.
I mean, there's a problem and there are well-known solutions to those problems.
See that?
You mentioned, you mentioned two different things, NoSQL and new SQL.
Yes,
Can you please explain those pieces?
I will talk to you one this time. Yeah.
Very briefly.
So you have the guarantees of a SQL database, but the underlying technology is suitable for distribution.
In case of
New SQL.
New SQL,
Something like complexity and
Cost of
IDP.
leasing, for example, different data models.
Spanner, Google Spanner. So far, I have drawn parallels between information and data. Now, and the next, I'll talk about the parallels between information and language. Numbers have labels. Between 0 and 99 in English, there are 10 plus 10 plus 9, 29 labels. For some reason, yeah, with these 29 labels, you can represent in words 100 numbers.
It's the alphabet.
I am not sure why they did 11 and not 10 1 instead of 21. Why?
10, 5, 15, 16, so they are 20
Yeah.
labels.
So 29 labels are used to represent 100. Again, my Hindi is not great. From
Hindi
what
has
I
100 labels.
Hindi has 100 labels.
I
The
think all
same-
Indian languages would
No,
have.
no.
No, Kannada doesn't.
Kannada, Telugu, at least they don't have. They are 29.
So they are 29.
29.
Okay, that's I thought.
So, for the same amount of information, you have two different schemes, 29 and 100. I will not be surprised if there is one language which does it with 20. Now, I remember this serial way back. There's this underprivileged guy who is telling his kid to do some push-ups. And he can't count beyond 20 in Hindi. So it goes like B's. Once it goes beyond 20, he just repeats 20, 20 and that's how he counts. I'll come back to that. There are two metrics in the world of medicine. Efficacy and effectiveness. Efficacy talks about how well medicine performs with a control set and how well it performs with the broader set or in the real world.
Effectiveness is the broader thing.
Yeah. Now, thankfully, Hindi stopped at 100.
You are missing that high component in Sama.
I'm sorry, again, I can say
Just
so, the philosophy that Hindi had chosen, if the counting was still 100, it would have sufficed. But the moment they came to 101 or 120, that scheme has failed and hence they moved to a compositional way of counting. So in the context of software engineering, when you build composable software, when you break down software into modules, such a way that they can be composed together, they can solve your current problems as well as possible future problems. I'll talk about aliases. What do you call a father's brother in English? What do you call the equivalent in say Kannada, Telugu or Hindi? Yes. So we distinguish between, Indian language distinguish between a father's brother and a mother's brother. Yeah, I was thinking about that. Now, what is wrong in referring to your father's brother as father's brother every time?
Too long.
Too long. That is why we have aliases for them in terms of Peddaya, Babaya, Babai, Chikappa and so on. Now this again has parallels in software engineering. If a piece of software is reused, instead of combining them in every time, you have a higher order abstraction. Concepts like facades and partial application in functional programming are all manifestation of this aliasing philosophy. Now one more Hindi. This is from the movie Chupke Chupke, I think. So there's a dialogue between why PUT is pronounced put and CUT is pronounced cut. This is an example of inconsistency. While Indian languages which are phonetic do not leave room for interpretation or inconsistency. So if you write software which is underspecified and has room for underspecification, this is a recipe for problems down the lane. So our software components should have clear dimensions of specification. Okay. Lord Rama is now in public discourse, so let me reuse. King Dasharatha had 4 sons: Rama, Lakshmana, Bharata, Shatrugna. Can you form a question in English about, okay, let me. Can you ask a question whose answer is Ayodhya in the context of Rama? What is the birthplace? Again, ask a question whose answer is Sita. Right. Can you ask a question about the 4 brothers? About Bharata, whose answer is second? Second.
Who's the second child of?
That is not a question. Answer is second. Yeah, please.
What is the chronological order of Bharata?
Who is Bharat?
So if you observe between the who, when, where, you see the effort involved in formulating this question. In Kannada, there is a interrogative verb, adverb saying estimate. It is a single construct. English speaker will have trouble formulating this question. This is an example of a missing concept in the English language.
That is the software integration barrier.
What is the question you said?
There is in interrogative adverb who, adjective who, which says who is a person.
Can you tell me? Example here, what is it?
Who is the younger brother of Lakshmana? I have an answer for that. Shatrugna is the younger brother. if I ask you, there's a first, second, third and fourth. What is the index of this person in this list? There is no equivalent in English.
And what is it in Kannada?
Yesterday.
Yesterday.
And I learned this in about Hindi. It is supposedly kaunsa way. It is supposedly gone out of practice. Yeah. In some languages do, some languages don't.
The idea is that we can have a specific word which specifically points to the positional order.
Yes. As a first class construct in languages.
In Hindi also it is, whatever you say is not.
It is forgotten.
Yesterday. In
Yes,
Kannada.
in Kannada. So, there's a takeaway from this. Our language influences our thoughts, that influences our, actually it should be this way, but yeah. The concepts of ubiquitous language in software engineering are introduced so that we have the same, we have powerful constructs to represent the domain entities, and that is what we engineers use in our communication. Missing abstractions can make this again a tricky problem and errors down the line. Focus on your representations. There may be data representations, there may be behavior abstractions, or there may be object representations. So, focus time on this aspect. Talking about information
Talk
overload.
about this thing, I remember there was a book called Programming Pearls. And in one of that there was one aphorism that says that show me your data and I'll show you what you're doing. Something like that. Show me your data structure or show me your data and I'll tell you what. So the idea is that data structures not largely define how you're going to do the processing. Which is, if we really think about it, that's Python named arrays and dictionaries are first class citizens, so a lot of the processing happens using that. While you see the idea of a dictionary array or a hash table is not a first class concept. We actually, possibly, lots of people want to avoid it rather than what you want to do with array. So I think that's exactly one similar thing that you are trying to say, like how people.
You're talking from the lens of a programming language.
Right.
I'm talking about a level above. As engineers, focus on your abstractions. Have conversations, speak in English, speak in different languages, figure out what is missing and represent that. Okay. Example would be Java introduced functional programming with method references. Moment that was introduced, a class of coding became possible. A class of issues went away. I'll speak about information overload, which I think is a common phenomenon. What is that? The
Political.
of India. India is a country of I think few million square kilometers. There is, but the outer ring road is not there. Kormangla is not there. Even if I come down to Karnataka, I don't see Kormangla or outer ring road. What would happen if the map had such detail about Bangalore, Delhi, Hyderabad? Information overload, and basically the map would be largely useless. Yes. Now, this map is useful by omission of data, omission of information. But not all information is omitted. Careful choice has been made about political boundaries, the name of the states, and the capital and key cities of this. of these three maps are useful? Depends. So different maps have use in different contexts. Actually, this is actually an interesting map. This is overlaying both the political boundaries of Karnataka and overlaying that with physical information. These two are political boundaries. These are political and physical information is represented in this map. What I intend to say is, there may not be a single view of information which satisfies all the universal set of use cases in the universe. You need to do a different combination of selection, projection and joining. That is when the information becomes used. While you have the select, project and the join in the data world, the equivalent in the behavioral world are these diagrams. Some of them are kind of here. A physical map is no replacement for a political map. An object diagram is not a replacement for a class diagram. Both have their place. A particular user might be interested in purely the political map, somebody may be interested in a physical map, somebody may look at India level, somebody may look at the city level. So different combinations of deep dives different subsections of data or different granularity are required for different use cases. Rebecca Brock is an engineer who I hold in high regard. She speaks about, she mentions this. A good model is one that helps you reason about behavior of a system. System 1 might require a higher emphasis on data model, or a different system might care about the collaboration or the interaction. A different system might care about the timing model. This is where the human ingenuity, human creativity comes into the picture. You need to figure out what is the right model for our system. When I was a junior engineer way back, my team lead explained to me message queues in the context of mailboxes. While I did not know about message queues, the metaphor of mailboxes immediately struck to me and I was able to anticipate what the system does. So, a choice of a good metaphor helps in reasoning about desired state, desired behavior of a system. Is it a control system? Is it a command and control? Is it a hierarchical system? These kind of metaphors can be used in interpreting information. These are two systems which have a large number of tabs.
The right one is Bangalore version.
India.
Not necessarily every lot of places you can make a mess, you don't need to bring back.
Now, one key difference is there are clear do's and don'ts in this world. When they change lane, when they get off interstate or a highway, how many cars can exist in a lane and so on. This is a free for all, do your thing work. The difference is no or few constraints, more constraints here. To maintain the integrity of this system, they chose constraints. Here is a lack of constraints. If you go back to one of the earlier slides, I speak about information as constraints. For any non-trivial system, the choice of constraints is an essential part of system design. So, we spoke about multiple ways of programming. C gives you, a programming language C gives you a lot more freedom. The choice of private variables and make things more constrained in object-oriented programming languages. Functional programming languages take out even more from you. As we are progressing, as what I think are progressing you see that programming languages are becoming less and less constrained, more and more constrained, sorry. So as systems evolve, higher degree should be emphasis should be focused on, should be spent on constraints. Anybody disagrees with this statement? How many of you have seen visually rich designs presented to you? Or what fraction of designs have a lot of visual content?
In general or in context of
Software engineering.
So the discussions normally happen on the visualization or what will be the flow of the data and all those things. We don't have those kind of things, but yeah, when you talk to it depends to whom you are talking to.
Yes. One of my pet peeves is most design documents are text heavy. The choice of pictures, charts, figures and diagrams are under-exploited in our design documents. This perspective, I guess, if we were to employ, would make our lives simpler. Yeah. Why do books have chapters? Why not one long chapter?
Segregate them into logical or semantic or
Yes. The same reason we should have modules in software. Folks, this may seem trivial, but the number of multi-thousand line classes, multi-hundred line methods I have seen in my career, I really wish I wouldn't have. Yeah, who you are. Talking about communication, there are two classes of information constructs, thriller and report. A good plot has twists and turns. They have occasionally intentionally mislead viewers. It delays jumping to the crux and comes to a grand finale. This is true about thrillers. Other is reports. Typically there is a summary, then you have one more level of data, information and so on. When I go watch a movie or when I go read a book, I prefer a thriller. But that is not what I want my day job to be. Code should be simple, straightforward, comprehensive. It should be modular, should have references, it should be normalized. It should not have 200 line methods and 1000 line classes. So, between these classes, these information constructs, our code, our document should be more reports than there are thrillers. So, given that software engineering, I restate, is about acquisition, representation, compaction, recording, organization, retrieval, display, dissemination of information. This is true for your machine readable code. This is true for inter-developer communication, inter-stakeholder communication. Take this perspective and we'll have a better work. Yeah, time for questions.
This is how this code qualities and those things comes into the places.
Code quality is one dimension. Design document is important. Are your requirements unambiguous? Are your requirements complete? Are your requirements, are they mutually incompatible? Is your design document complete? Or what part? Do you have models? Do you use pictures, diagrams and models to communicate, or do you have long verbose text? Are those documents and your code thrillers or are they reports?
That is domain design. Domain-driven design.
Domain-driven design is making the information about domain a first-class construct. And the emphasis on ubiquitous language is again, I spoke about language. The widget, those kind of abstractions are first-class construct in the programming world.
You briefly touched to normalize versus denormalize databases or as the world is moving towards denormalized databases. So what are your thoughts?
No, world has moved to denormalized. Now it's making come back to normalized world because the trade-offs are the better options for
What would be your advice to keep the code clean?
make things human consumable. I have a 4D version of the same content. When things are small, you can afford a degree of chaos. When system size increases, unless you impose constraints, you will not get the stability and integrity of the system. The choice of your private variables, the choice of your final key or keyword, figuring out what visibility each construct has, all of those is where I would spend time. Would you want to represent the information with equivalent of 29 labels or 100 labels? Those are the things I am trying to bring your attention to.
Generally, there is a, when you start small, you can go, like you said, like it's okay to not have.
It is okay. Let's go with it.
As and when your system grows, there comes a point when you understand that now many things have happened. Now it should be. So what is that point which you would should stop that and you should start doing that? Because usually what happens is systems grows very big and then we realize this happened, then it's very hard to go.
Follow up to that actually, how do you add constraints to a chaotic system which is already existing?
Yeah.
It's on production. So
I'll come to your question. How do you, given an array of integers, how do you find the fourth largest integer in that array? How do you find it? Give me outline of the algorithm. Give me the outline of the algorithm.
I'll have a different array. Set the first, get the maximum and then keep going down.
4 times.
Yeah.
How about 23rd gets element in the array?
Then you can change that.
What would you algorithm? Sort. I will sort it. Would you put sorting as a different method, or would you keep it in this find 23rd element? Why? How many lines of code will this be? 8 lines? 10 lines? In 10 lines, you chose that a particular piece of code should have a separate existence. Even within 4 lines, there is value, or within 10 lines, there is value on this approach. More importantly, you need to build the information management muscles. If you do it at the code level, you have a higher probability of attaining at the component/microservice. That is my argument. So, what was your question?
My question was, how do you add constraints to a chaos which is live on production? So it's not like you can change the entire system.
No. This is an aspect where still humans will outbeat AI. So this is where I guess our ingenuity and intelligence comes into the picture. This is the other end. You have a fairly large system with no constraints. You have to start drawing boundaries. This island here is good in this way, this island has this way. Then this islands will converge and you have higher degrees of sanity, bigger islands of sanity. That would be my approach. Yes, please.
Actually, following constraints, right? This is non-humanly. I prefer to use shortcuts. We prefer to take cuts which will make us reach to a destination faster. My point here is, when consider I have to convince my junior developers to follow certain principles, certain constraints, but then they see it is easily achievable.
Yes.
I can simply take a shortcut and I will get that.
Yes.
At that point of time, it gets very difficult to convince them no, you have to follow this. But they have this urge to take these shortcuts and they stay unconvinced in
yes.
So how do you handle this kind of thing?
The intent of me coming and talking this forums is to influence upon people like you. Sure. Jokes apart, between a C and C++, they introduce the keywords final and private. If you go to function programming world, immutability is a first-class construct. You have an example of why people have done this. I can point you to videos where people talk about this at more length. So, my first step is to impress upon people like you. I'm not sure everybody in this audience had appreciation of constraint, thinking about constraints as a first-class construct. If you give people a set of principles, they will nod their head and then forget by the end of the day. In the context of the code they have, if you say, this is the refactored code, this might be better for these reasons. The combination of analogies, metaphors, real-world examples, and code examples is what I have employed. Your mileage may vary.
There is like some trees, no branches in the from the branch.
Yes.
No trees
Yes.
So to accept space, and sometimes if the code and the system is too big and has problems, then we need to take that as
Yes.
very big pieces, don't throw the whole thing away. Big pieces and start with the constraints.
Folks, most of the ideas are actually well known. Another thing I want to impress upon you is there are enough thinkers within the world of software engineering. There are enough writers and speakers. I think we have a problem with the other bucket. People who read and people who watch. So, let's spread the word.
Okay.